Hi guys, welcome back to 360DigiTMG's domain analytics program. In last class, we have discussed about what are the applications we will be having when it comes to banking and insurance analytics. So where exactly we will be using the machine learning algorithms or AI. So how can we improve the analytics when it comes to banking and insurance that we have gone through? Various applications we have seen how we can find out or predict who's going to default the loan or not, whether that particular person going to pay back the loan, entire loan or not. So, and when it comes to medical health care, whether we should give, claim, whatever the claim that we are getting, insurance claim, whether we should approve that claim or not. So for that, how we can use the machine learning algorithms or AI, those applications we have discussed in the last session. Today, we will be discussing about the methodology, that is CRISP-MLQ. So CRISP-MLQ methodology, what exactly the CRISP-ML methodology and why we need to use this CRISP-ML methodology, and what are the phases we will be having when it comes to CRISP-ML methodology. All those things we'll try to understand today. Previously, we used to have CRISP-DM, that is cross-industry standard process data mining. We used to have CRISP-DM methodology, and then monitoring and maintenance. That phase we didn't have in the CRISP-DM, and it is replaced with CRISP-MLQ. So in that, we have added monitoring and maintenance additional phase. That is the reason we will be calling it as CRISP-MLQ. That it means machine learning and quality assurance. So what exactly the CRISP-ML methodology is? Why we need to use the CRISP-ML methodology? Say in order to do any data science project, irrespective of any domain, whatever the domain is, in order to do the data science project, we need to follow some hierarchy, some order we are supposed to follow in order to increase the accuracy of that particular model. So that we will be having CRISP-ML. It is one of the it is the best method that is followed all over the world in order to do the data science project. So what exactly it is? What are the phases we will be having? All those things we'll try to learn in this session. So it is the second session of the domain analytics program, that is in data banking and insurance. We haven't watched the very first one. The applications when it comes to machine learning applications when it comes to banking and insurance, you can simply go through the playlist and you can watch the very first video. Yeah. So yeah, without wasting time, we'll see what exactly the agenda is. First, we will go through stages of analytics. So what are the stages we'll be having? Phases and stages, both are different. Stages and phases. So what we will be having in stages, how we will be trying to, how we will be solving the business statement. So we'll see that into the in the stages of analytics, and then we'll go through CRISP-MLQ, that is phases that we'll be having when it comes to data science, and inferential statistics. What exactly the inferential statistics is and how it will be useful when it comes to data science projects. Unsupervised and supervised. So when it comes to data science, two main algorithms will be having: supervised and unsupervised, and we have semi-supervised as well, but very extensively we will be using supervised and unsupervised. And data split. So while doing the training, we will be splitting the data into various, like train, test, and we'll be having one more called validation. So various will be having why we need to do this many splitting. So what is the reason behind it? So that we'll try to understand, and error functions will be having. So once the model building part is done, how can we evaluate that particular model? So whatever the model that you are building, how accurately it is performing, how many classifications it is doing correctly, if you are going with the classification algorithm, how many it is doing the misclassification. Based on that, we will be calculating the accuracy of that particular model, right? So in order to evaluate that particular model, we will be having error functions, and we will be having overfitting and underfitting. So what exactly the overfitting and underfitting also we'll try to understand in this session. So first, we'll see what exactly the stages of analytics is. So let's say any problem statement. So one client came to you with one problem statement saying that we are seeing a significant amount of increase when it comes to NPS. So it is a banking client. Let's say banking client, he has came up with one problem statement saying that there is a surge when it comes to NPA. What is NPA? Non-performing assets. Non-performing assets. So what exactly that means? Say you have taken a loan from one bank, it is XYZ bank, let's say, and you are supposed to pay back that particular loan in EMIs. Every month installments will be having it. So every month you are supposed to pay this month's amount, X amount, let's say. So you are not paying from last 3 months. You're not paying from the last 3 months. In that case, your account will be called as NPA. You are the one who's not paying back those loans. In that case, we'll be calling it as NPA account, non-performing assets. So they have come up with one problem statement saying that we have huge surge when it comes to NPA, and we want you to reduce it. So that is a problem statement they have come up with you. You are the data scientist. You are the data scientist. You have to go through the data and you have to analyze it. So what happened? In descriptive analytics, what happened? What happened? There is a huge surge when it comes to NPAs. So that is our problem statement. Why that happened? Why that happened? How can we know that why that happened? When you go through the data, so when they have approved the loan, in that case they will be having data of each and every person, right? Whoever they are approving, so they will be collecting the data regarding that particular person. So they will be having huge database storage regarding each and every person. So we will be analyzing the whole data, and using that we will be coming up with inferences saying that because of this reason, you got this. Because of that reason, there is a huge surge in the NPA. So what is going to happen? So whatever the historical data we have gone through those historical data. Based on that, we have found out that because of this reason, there is a surge in NPA. So what will happen if it is still continues? So what is the future of that particular company or the bank? So what are the outcomes that they are supposed to face? So that prediction will be doing using predictive analytics. So what is going to happen? What is going to happen? So what happened? That is the problem statement. Why is that happening? We will be finding out using the analytics, diagnostic analytics. What we'll be doing? Diagnosis. We'll be going through the data and we'll try to find out. Predictive analytics. In future, what is going to happen? So what kind of decision that we can make? So these are called as prescriptive analytics. Based on all these, finally, we will be making some business decisions. NPS search, what could be the reason? If it is continuous, in that case, it will be a, any bank. If there is huge number of NPS, piled up, in that case, it will be difficult to survive for that particular bank. So what kind of steps they can do? So like that, for this, we can build one machine learning model. Saying that, what kind of machine learning model can be built? So based on whatever the inputs they are taking in order to approve that particular loan, what are the inputs they are taking? Based on those inputs, we can build a machine learning model. Let's say salary they are considering, age they are considering, experience they are considering, some other skilled job or not skilled job, that is also they are considering. So based on that, they are approving the loan. Based on that, they are approving loan. So the same historical data we can take and we can build algorithm saying that whether we should approve that loan or not. If your model is performing really good, and let's say if your model is giving about 95% accuracy, in that case, so whatever the trouble some cases will be having, the people who are not able to pay back. So among 100% people, you have removed 95%. Only 5% we have, we might do misclassification. So in that case, you will be reducing those NPS, right? So the huge amount of NPS you will be able to reduce. So this is how we will be working on. So this is how we'll be building. So these are, we'll be calling it as stages of analytics. First, we'll go through the historical, the problem statement, what happened. Why is that happened? That we will be doing the diagnosis, and what is going to happen if it is still continues. So that is, we will be doing the predictive analytics. Finally, based on these inputs, we will be making decisions, that is prescriptive analytics. So these are all whole stages of analytics, all 4 stages of analytics in comes to data science. I hope you got an idea what exactly the data, stages of analytics is. And then so yeah, this is the stages of analytics. The same, you can take so many examples, like say, yeah, you got fever, problem statement, you got fever. So when you go to a doctor, a clinic, so you'll be saying that, yeah, I got fever. So in that case, what the doctor will be doing, he will try to go through your data, historical data. If you have gone through any tests, so he'll go through the data, and he'll be asking some questions. Are you went to some new places? If you are traveling to new places, because of that also you can catch fever. Because if you are going to new places, in that case, water will change, right? If you use that water, in that case, also you might get fever. And weather could be one more factor. Weather change also could lead to the fever. So he'll be asking few questions, and he will be asking whether you have any water repositories nearby your home, so that because of that mosquito development, and because of that you might be getting dengue as well. So like that, he'll be asking few questions. Those are what historical data that he'll be asking you, and he'll be doing some tests as well. That is what diagnosis. He will be doing the diagnosis, and then he'll come up with the reason. So because of what that you got a fever, whether it is because of mosquitoes that are around your home, or because of you have traveled to some other place, because of weather or water change, something like that, various options will be having. Going through all the data, he will come up with saying that, yeah, this is the reason, reason, this is the reason you got that fever. So what we can do? So what is going to happen? It might, if it is dengue, in that case, you might take like a few more days in order to come out of that fever. Something like that, he will be doing the predictions, and based on that, whatever the diagnosis is done, he will be doing the prescription at the end. So this is also, you can apply the same thing. You can apply on any case. So these are, we'll be calling it as stages of analytics. The sequence is very important: D square and P square. Descriptive analytics, diagnostic analytics, prescriptive, predictive, and prescriptive. Predictive means here we'll be using all the machine learning models. Machine learning models. ML algorithms, you can say decision tree, KNN, and there are so many logistic regression. There are so many algorithms we'll be using in this stage only. Predictive analytics. Diagnostics means we'll be using all the visualizations. What we are doing, why we are doing the visualization, so that we can find out any inferences that are hidden inferences we'll be having right in the data. So if you do the visualizations, in that case, you will be able to find those reasons. And then finally, we'll be doing the prescriptive analytics, means we'll be making the business decisions. So descriptive analytics and diagnostic analytics, up to here, data analyst people do. And this predictive will be done by data scientists. And the business decision will be taken by subject matter expert. So these are the stages of analytics when it comes to data science. So then we'll jump into what exactly the CRISP-ML methodology is. So these are the stages, right? What exactly the phases? So what are the various phases we'll be having, and what we will be doing in each and every phase, we'll try to understand. Yeah. Project management methodology, that is CRISP-MLQ. We'll calling it as CRISP-ML. What exactly the CRISP-MLQ is? Like I discussed, cross-industry standard process and machine learning quality assurance. So cross-industry, name itself saying the cross-industry, irrespective of any domain, any industry, whether it is agriculture, healthcare, HR, supply chain, legal and law. So various domains we will be having, irrespective of any domain, we will be applying the same CRISP-ML methodologies. So what are the phases we'll be having in those? We'll see now. Business understanding, the very first other phase, we will be having business understanding. Whatever the problem statement given to you, you have to go through what exactly the business understanding, what exactly the objective, what are the constraints we will be having. So what are the business perspective? What kind of profit that will be getting, economic understanding also will be having, like various will be having. First, we need to understand what exactly the business statement is talking about. So with that, we can come up with business objective. So what is our end goal? So it could be in various form, like some people might be coming up with some business objective, some people might be coming up with some other business objective, but end, we will be resolving the one problem only. So it is business objective, and then we will be having business constraint. If you are doing that particular project, what are the problems that you're going to face? So that we will be calling it as business constraint. Business constraint. So we will be recording all these things when it comes to business understanding. And then when it comes to data understanding, we have various types. One, we will be having discrete or categorical data. And we will be having numerical data. Broadly, it will be classified into categorical and numerical. When it comes to numerical, we will be having decimal, and categorical will be having discrete. In discrete, we have categorical, count values, intervals, various data types will be having. That we'll be trying to understand. Why do we need to understand that? Why do we need to understand the data? Because when you are working on the project, most of the time you won't be able to, you won't be given the data. Most of the time, the data won't be given. What you have to do, you have to go out there and you have to scrape the data. You have to go out there and you have to scrape data. While you are collecting the data, scraping the data means various websites you are going and you are picking the data. While you are collecting the data, which data you have to give priority? So various data types will be having which data you have to prioritize. So to understand that, you need to have a data understanding. Which data will be giving the maximum information? Which data I have to prioritize? When I'm picking up, which is the data I have to give a least priority. So all these things you will come to know when you know the data understanding part. So, and then we will be having the data preparation. So what we will be doing when it comes to data preparation? So whatever the data that you are collecting from various sources, that will be raw data. So when you have a raw data, so many anomalies will be having, like missing values will be having, duplicates will be having, extreme values also will be having. So various anomalies will be having in your data. When you have these many anomalies, you can't directly feed the data into the machine learning model. So in order to, we have to do the pre-processing. In order to do the pre-processing, we have so many techniques. That's all comes under data preparation or data engineering. It will be coming under data engineering. So once the data engineering is done, data preparation is done, what we will be doing? The same, the data that we have completed, pre-processed. Our pre-process will directly feeding into machine learning model. So here we'll be starting model building and tuning. So when it comes to model building, we have various machine learning models like supervised, like we have explained, supervised, and we have unsupervised. And these are the main very frequently used algorithms, and then we have semi-supervised, supervised as well. So we don't need to talk about that now. So mainly we will be using this supervised and unsupervised only. So once the model building is done, what exactly the supervised is and what exactly the unsupervised is, we will be discussing in detail in upcoming classes. But for now, you can simply remember that both comes under model building part. So once the model building is done, we will be having parameters. For each model, we will be having some parameters. So using those parameters, we'll try to tune the model. So at what parameter it will be performing great. So at what parameter the model is performing great. So we have to understand that part as well. So what we will be doing, we will be changing those parameters. If you have 10 parameters, 10 times you have to change the parameters and we have to note it down. At which parameter it will be performing great. So when you know that, in that case, that parameter only will be taking into the consideration so that we can increase the accuracy of the particular model. So once it is done, we will be doing the model evaluation. So for the model evaluation, we'll be having error values or error matrix, something like that. So in order to evaluate how good your classification algorithm is working, how good your regression model is working, to know that we will be doing the model evaluation. And once it is done, all checks are done, we'll be doing the deployment of that particular model. So once deployment is done, deployment means we have various web frameworks will be having, cloud will be having, and there is local servers also will be having. So there are so many sources we'll be having. What we are doing, we are simply deploying that model. Once the deployment is done, we will be monitoring and maintaining that particular model. So I mean, the data science project is nothing like, it's just like 1 month and 2 months and it is done. It's not like that. Every time data will be changing. Data will be changing. So according to the trend and the new data, we have to train that algorithm again and you have to deploy it again. Each time you have to change that data again and you have to deploy it. It is continuous process. It is keep going on until and unless data will be changing. So pre-COVID era, you might have an idea about pre-COVID era. Previously, we don't have any understanding about the sanitizer. But now everybody is know, right? Everyone is know. So if you use the same data, pre-COVID era data, now it won't be applicable. So what we will be doing? A new data. So monitoring and maintenance will be having right here. We will be keep training the algorithm based on the newly available data. So these are the phases and what happens. Briefly have gone through it. So what is the business understanding? What we will be having in business understanding, and what is the data preparation? What are the various techniques we will be having in data preparation, and model building and tuning. What exactly we'll be doing in that, and model evaluation and model deployment and model monitoring and maintenance. What we will be doing, that we have discussed. Now we'll understand what exactly the unsupervised learning and what is supervised. What is unsupervised and what is a supervised algorithm? We'll try to understand first, and then we'll get into how we will be building the models and how we'll be evaluating the models that we will. Let's say unsupervised. So what exactly the unsupervised is? Let's take one COVID data. So these are features x1, x2, x3, and x4 and y. Let's say these are the features, and I don't have y here. Also I have x5. So here what I'm taking cold, whether that particular person cold as COVID data. Let's say take COVID data only. X1, that is cold, whether you have breathing issues or not. And smell, whether you have a smell or not. Taste, whether you have taste or not. And we have taken some other, that is whether you have fever or not. And then we have output saying that y. So these are the input features I am considering in order to tell whether that particular person has a COVID or not. So in that, in historical data, let's say this is yes, 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 yes. In that case, I have a COVID, yes. And if any one of those things in that case is no, in that case, we are saying that no. So it is not, we are saying the historical data is present like this. So you can see here the output. So based on these features, we can tell that, yeah, whether that particular person or that particular person have COVID or not. So this data, the output data, will be called as labeled data. If you have a data frame, in that, if you have labeled data, if you have a data frame, in that, if you have a labeled data, in that case, we will be going with supervised. Supervised means working under some supervision. Supervised means working under some person's supervision. So we have output, and under the output only we will be taking those inputs into consideration, and we are simply giving that whether it is a positive case or negative case. But when you don't have this output, when you don't have this output, in that case, what we will be doing? So based on the features, whatever the features we will be having, whatever the features we will be having, we'll simply group into various categories. It could be anything. It could be one, one doesn't make sense, and two categories, maybe three categories, various categories will be having it. Like that, it will be forming groups or clusters. We will be calling these are clusters. When you don't have a label data, you will be having clusters or groups, and when you have a label data, in that case, you will be getting the prediction here only based on the new data that is has been inserted, so that it can make a decision saying that it belongs to the positive case, that is COVID positive, and it belongs to COVID negative. Based on the historical data only, we will be judging that. If you don't have any historical data, in that case, we won't be able to do anything. When you have a historical data, we will be cleaning that, and we will be feeding the data to the machine learning model so that it can come up with the various classes. I hope it is understand what is the supervised and what is the unsupervised. Unsupervised, we don't have any output. Algorithm itself go through each and every data, and it will simply form clusters or groups. So how it is happens, unsupervised learning, how we will be training the machine learning algorithm that is unsupervised. So unsupervised means when you don't have a target or label data. When you don't have target data or label data, in that case, we will be calling it as unsupervised. We will be going with unsupervised learning. Historical data, first, right after the pre-processing only will be starting. Pre-processing is done. The same data, historical data, I am simply feeding to the machine learning model. I am feeding to the machine learning models. So machine learning models, it will go through each and every data type, data or inputs. All the inputs that we are giving, it will simply go through all, and based on that, it will come up with some rules and patterns. It will simply come up with rules and patterns. We will be using these rules and patterns to judge the new data. We will be using those rules and regulation we will be using those rules in order to segregate into various categories. Let's say we have done machine learning algorithms. You got the rules. Again, I have taken same features, whatever the features that I have trained that COVID algorithm, unsupervised algorithm. whatever the features that I have used in order to build that particular algorithm, that is unsupervised algorithm, same I'll be passing. So whatever the features we are passing to the machine learning models, based on those patterns, it will simply categorize into a cluster, whichever the cluster that belongs to, it will simply cluster into that. So based on what it happens, rules. So we don't have any target variables. We don't have any target variables. So based on the data, it will simply go through the data and it will create itself, machine learning algorithms will create the rules. And based on these rules, whatever the new data that is coming in, we are judging those data. So like that, we will be doing the predictions. So like that, we will be doing the prediction when it comes to unsupervised. So here we don't have anything like splitting the data into train and test. We don't need to do that. So whatever the new rules patterns will be having, again, new data we are passing, and based on that, we can get the outputs. Based on that, we can get the outputs. So this is what happens when it comes to unsupervised learning. So similar, I mean, it is an unsupervised learning. We have supervised learning as well. So what happens when it comes to supervised learning, that we will see now. Supervised means when you have a labeled data. Labeled data means when you have an output data, that is why dependent variable also we can call. Dependent variables will be having. In that case, we will be going with labeled data or target data. In that case, we will be going with supervised. So what will be happening when it comes to supervised? So whatever the data that we will be having, so it will be simply splitted into train and test. So let's say it is a historical data. So whatever the inputs that we'll be taking, so very random. So whatever the inputs that we are taking that are very random, and we will be splitting into train and test. So the train test size are completely different on the size of the data that you will be having. But if you have a medium level data, in that case, we will be going with 80-20 ratio. So I'm giving 80% for the training data and 20% for test. 80% for train data and then 20% for test will be having. Using this 80% data, I'll be training the machine learning model, and the test 20% data I'll be having it. I'll be passing machine learning algorithm to test it, how good it is performing. How good that machine learning algorithm is performing. So whatever the output that we are getting, that prediction or validation output that we'll be getting, so that model will be doing the evaluation. Historical data will be having. So labeled data, that means output you have. So what that output we are randomly sampling and it was splitting into 80-20. So training for 80% for training and 20% for testing. And then the same data we are passing to the machine learning algorithm. So whatever the machine learning algorithm you are using, it will simply go through all the data set and training data set as well as testing data set, and it will come up with predictions. So that prediction, how good it is. So for that, we will be using the model evaluation. For that, model will be, how we will be doing the model evaluation? Again, you will be supplying the new data for the whatever the model that we have built, and we have to compare it, how good our model is, how accurate it is giving the results. So like that, we will be coming up with prediction. So here one more thing we have, training data, testing data, and validation. So training data and testing data we have seen. What exactly is this validation data? Why we are using that validation data, we'll see now. So like we discussed earlier, the data is split into train and test. So when you have more number of hyperparameters, or simply say parameters, when you have more number of parameters, we don't know, right, at what parameter that model is gonna work really well. So we don't know. So each time we are passing the data with new parameter. So in this cyclic process, the data leakage might happen. In this training, we are doing the training the model using training data, and we are testing the model, and we are validating the model. So validation data will be taking to set which parameter is performing great. So at each time we are giving the data, right? In this process, cyclic process, data might get leaked to the validation data, in algorithm. So in that case, it will lead to false accuracy. False accuracy rarely happens. In order to avoid that, we will be going with test or validation. Validation, if you are using for parameters, in that case we will be testing the model using the test. Testing, if you are using test data for the validation, in that case you can go with the validation. Testing and training and validation. Simply we are splitting the data into train and test and validation. Train means whatever the train data will be having, based on that only will be training the model. And testing means whatever the data we will be having, we are simply whatever the model that we are built, we are simply testing that model using the test data. And validation, if you have more number of hyperparameters, if you are having, in that case, which hyperparameter will be performing great, which parameter will be performing great, for that we will be using the validation. So this is the supervised learning, training and validation and testing. So like that, we will be taking the validation, testing and training. So let's say we have built one model. Let's say we have gone with classification. So what exactly the classification is? Let's say you have a label data, right? Label data. What is label data? You have inputs. We have taken age, salary, experience, and something else, and we'll be having that output. So these are all inputs, and this is output. Inputs and output. If this output is in the form of categorical data, if the outputs in the form of categorical data, in that case, we'll be going with classification. If the output is categorical data, in that case, we'll be going with classification. If the output is continuous, if the output is categorical, in that case, we will be going with classification. If it is continuous or numerical, in that case, we will be going with regression. Continuous, regression, and if it is categorical or Boolean also. Yes or no? In that case also, we will be going with the classification. So that is the main difference when it comes to classification as well as regression. So let's say we have built the model. So how you will be evaluating that particular model? So based on what you will be doing the evaluation? To evaluate the model, we have error functions ways. So confusion matrix will be calling it as our error functions. So what are the error functions is, let's say you are going with the classification model. Classification model means if output is categorical. Let's say we will be taking the same example, COVID data, and you have taken the data frame. In that you got output is yes, COVID, or no, no COVID. Yes and no. Just two, right? That is also categorical data. That is also categorical data. When you have a categorical data in the output, in that case, you will be going with the classification. When you are doing the classification model, how good your model is working? How much accuracy? How we will be deciding that? How we will be doing the model evaluation? So that we will be, for that we will be having confusion matrix. So what exactly the confusion matrix is, I'll go through very briefly. Let's say, yeah, you are trying to predict the disease. You are trying to predict disease of patient. Any patient, whether it is any kind of disease, irrespective of any disease. What we are trying to do here, we are simply classifying which whether that particular person has the disease or not. We will be having actual data and we will be having predicted data. Predicted data means main data frame, real data, and these are the predicted data we will be having. So whatever the actual data and predicted data is both true, in that case, actual data and predicted data both true, in that case we'll be calling it as correctly classified case. If the both actual data and predicted data both are same, in that case we'll be calling it as correctly classifying. If it is misclassifying, if actual data is negative, COVID negative, and your prediction says COVID positive, in that case it is not true, right? So both actual and predicted cases are both same. In that case, we'll be calling it as correctly classifying the data. If not, in that case, we call as misclassification. You can take the same exact example. Disease present, it is a predicted cases and these are actual cases. If disease is present and you are saying that it is not present, the prediction. So prediction is what? Let me explain this way using these examples only. So what are the correctly classified cases? What are the misclassified cases? What is false negative? What is the true negative? All those things we'll try to understand. True positive. If the let's say patient has disease, and you are predicting the same. Patient has a disease. Patient with the disease is told that he has a disease. In that case, we will be calling it as true positive. Patient has a disease and we have also predicted saying that it is a positive. In that case, we will be calling it as true positive. Patient with no disease. Patient doesn't have a disease, but the prediction that we are doing, it is saying that it is also not disease. Patient is not having disease. Our prediction is also saying that it is not having disease. In that case, we will be calling it as true negative. And we'll be having false negative, patient with a disease. And we are predicting that, saying that he doesn't have a disease. In that case, we will be calling it as false negative. Patient has a disease, but our prediction is saying that he doesn't have a disease. True positive, both are same, that are positive. True negative, both are negative. False negative, patient with a disease. Patient has a disease, but our prediction is saying doesn't have a disease. In that case, we will be calling it as false negative. These are very deadly. False negative cases are detrimental, very dangerous. Say, let's consider cancer person cancer prediction that you are doing, whether that particular person has a cancer or not. Whether that particular person has a cancer or not, you are predicting. And what you have built a model out of that. And patient has a disease, that is cancer he has, but you are predicting, your machine, whatever the algorithm that you build, it is saying that you don't have a disease. In that case, false negativity. So when you have a false negative case, in that case, people, I mean, whoever the person, that patient came to you, he will relax. He won't go for treatment and all because he doesn't have a cancer, he will assume. After some time, maybe at the time he came for the diagnosis, he will be having just first stage. After some time, if he comes to know, in that case, it might be in the last stage of the cancer. In that case, because of your model, one life, completely going to lost. So false negative cases, you have to keep in mind, especially when it comes to healthcare domains, healthcare analytics. In that case, you have to make sure you don't have any false negative cases. And then we'll be having false positive. False positive means patient doesn't have a disease, he doesn't have disease, but our model is saying that he has a disease. Patient doesn't have a disease, but our model is saying that that particular person has a disease. In that case, we will be calling it as false positive. It won't be a big issue, but when it comes to false negative, it is very dangerous. So how we will be finding out the accuracy of the particular model? Classification. How can I find out the accuracy? So to find out the accuracy, we will be having one formula: true positive plus true negative by total. Or you can simply say true cases by total. In total, what we will be having? All true positive, true negative, false positive, and false negative. All combinedly, we will be calling it as accuracy. You can see here, true positive plus true negative by true positive plus false negative plus false positive plus true negative. This all comes under, we will be calling it as accuracy. So when you know the accuracy, in that case, we can easily able to understand what is error rate. The total, how much it is? 100%, let's we consider. Accuracy got 95. In that case, 5% we will be having error. 5% you will be having the error. So accuracy, it is true cases by total, and error, we will be calling it as total 100 minus accuracy. We will simply able to calculate what is the error rate. 95% accuracy means 5% is error rate, obviously. So this is the error function when comes to classification cases. It is an error function when it comes to classifications. And next, what we have, precision. What exactly the precision is, we'll look into it. What exactly the precision? Let's say you have done model building, completed model building, and you have deployed that particular model. You have deployed a particular model. Precision means how accurately your model is performing. So let's say some random person came We are not working on the historical data now. We have deployed that particular model. Random person came for the diagnosis. Using our model, he is trying to do diagnosis. The probability of that, if that particular person has a disease, the probability of correctly identifying a random patient with a disease having a disease, that we will be calling it as precision. So how accurately your model is performing, that is what we will be calling it as precision. Probability of correctly identifying a random patient with a disease having a disease, that we will be calling it as precision. We have formula true positive by true positive plus false positive, that we will be calling it as precision. And then we will be having sensitivity. We'll also call it as recall or hit rate, or hit rate it is, and true positive rate. So what exactly it is? Let's say COVID cases. Total 1,000 COVID cases will be having. Among that, 70. Let's say 700. 700 are positive cases and 300 are negative cases. Let's assume that. When I'm explaining the sensitivity. Proportion of people with the disease who are correctly identifying as having a disease. Let's say people having a disease is 700 members. Among these 700 people, how many of them you have correctly classified as COVID positive? That we will be calling it as sensitivity. Among these 700 COVID positive cases, how many of them you have correctly classified as COVID positive? And similar to that, we have specificity. Here, among all the negative cases we'll be having, how many of them you have correctly classified as a negative? So this we will be calling it as specificity, sensitivity and specificity. When it comes to negative cases, or true negative rate, you can also call true positive rate for the sensitivity. And then we'll be having FP, false positive rate. So what exactly it is? False positive rate, that we'll also call it as type 1 error. For that, we'll be calculating 1 minus sensitivity. So whatever the data that we are getting, or the output that we are getting, we can simply use here to calculate the false positive rate. So we will be having precision and recall rate. So to balance both, see, when you don't have a domain knowledge, if you have domain knowledge, in that case, you will be having an idea which one you have to go with, whether you have to go with the precision and whether you have to go with the recall. But if you don't have any domain knowledge, in that case, we have to balance both. That we will be getting from the F1 ratio. What exactly the F1 ratio is? It is balances both precision and recall. So the formula for F1 ratio is equal to 2 into PR by P plus R. 2 into precision into recall by precision plus recall. We will be calling it as F1 ratio. So this is the error functions of confusion matrix when it comes to classification. These are all applied when it comes to classification. So we have an idea about error function when it comes to classification. But how about regression? What are the error functions we'll be having when it comes to regression? That we will see now. So what is regression? When you have output or the labeled data. When you have an output or the labeled data are in the form of continuous data. Continuous data. When you have a labeled data is continuous. In that case, we will be going with regression. In that case, we will be calling it as regression. So what exactly is the regression? You will be getting the numerical output, right? So how we will be finding out the accuracy of that particular model. So what are the error functions? What are the error functions we'll be having when it comes to regression? We'll see. So we have so many error functions when it comes to regression. Among the mean error, mean absolute deviation will be having, mean square error will be having, root mean square error will be having, mean percentage error will be having, mean absolute percentage error will be having. These all comes under error function, but very frequently we will be using mean root mean square error. So why we are using that, we'll go through it. So let's say this is actual data. The actual data will be having, and it is a using the model. You have done one model, and using that we have predicted this model. Predicted this. So this is actual data and this is predicted. Actual and predicted. The difference only we will be calling it as error, right? So 100 minus 101 predicted and the actual. So how much difference we have? 1. Here minus 1. Here minus 1. And again minus 1. So this is the error that we got. How much error total we got? When you calculate their mean of these errors always equal to 0. But is it 0 in real? In real time, is it exactly 0? No, it is not 0. Is it exactly 0? It is not 0. Even the mean is we make it real. So for that we will be using the mean square error. So whatever the difference we will be having, we are simply squaring it. So same here, when you calculate the mean of the mean of the value, in that case also it will become 0. Here, if you square it, so what will be getting? 1 square plus minus 1 whole square plus 1 whole square plus minus 1 whole square. Overall, how much we are getting? 4. Yeah, exactly. You will be having that 4 error. But here, if you square it, so you will be getting 400. Is it the 400 is your error? No. So it is not 400. We have got about 40. So it is not representing the actual value. That is the reason we are going with root mean square error. So whatever the square data will be having, will bring down those into actual values. So for that, I'll be using root mean square error. That means mean square error will be having a square. Simply we are adding the square root. That is only we will be calling it as root mean square error. So accuracy, obviously accuracy plus error is equal to 100 and accuracy plus error is equal to 1. So we'll be using 100% and sometimes we'll be using as accuracy 0 to 1% or 0 to 100%. Something like that we will be representing when it comes to accuracy of the model. So it is when we will be using this when you have a regression. And then we will have overfitting and underfitting. What exactly the overfitting and underfitting? We'll try to understand. So when you are splitting the data into train and test, when you are going with the supervised, we have to split the data, right? The main data will be having train and test. Let's say you are giving 80% to train and 20% for test. When you are testing your algorithm, you will be getting the accuracy, right? Training accuracy you will be getting, and testing accuracy also you will be getting. If that training accuracy is high and testing accuracy is low, training accuracy is high and testing accuracy is low, in that case we will be calling it as overfitting model. Let's say training accuracy you got about 90% and testing accuracy is just 70%. In that case, we will be calling it as overfitting. That is also called as variance. When the training data accuracy is high and testing data accuracy is low, in that case, we will be calling it as variance or overfitting. Similar to that, when training accuracy itself low, when training accuracy itself low and testing accuracy obviously it will be low. In that case, we will be calling it as underfitting. We will be calling it as underfitting, or we can call it as bias. We'll be calling it as underfitting or bias. So this is the overfitting and the underfitting. When right after doing the accuracy, right after getting the accuracy of the model, we'll look into whether it is overfitting model or underfitting model. So this is overfitting and underfitting. So how it is happens when it comes to regression, how it is happens when it comes to classification, we'll say. So when it comes to overfitting or variance, we can call it as underfitting, or bias, we can call it as. So how it is happens? Let's say this data. So this is my data. Data is non-linear. When you look at the data, it is non-linear. If you do one prediction, that is in the form of linear data, regression line. So it is a prediction rate. So these are the actual data and it is a prediction. Data is non-linear and you are doing the prediction using the linear. So in that case, you will be having so much difference, right? You'll be having so much difference. That difference leads to so much difference when it comes to training and testing accuracy. This leads to overfitting. Sorry, underfitting it is. Underfitting. So training data, training accuracy itself very low. In that case, it will lead to underfitting. This will be calling it as bias. When data is non-linear, but you are giving the regression line of linear, in that case, definitely it is not going to perform well, right? So then what we'll be doing? We'll be changing. Based on the non-linear data, we'll be building the non-linear model only. In that case, we will be able to decrease. We'll be able to decrease that particular error. We will be decreasing the error. So here we can say that it is a best fit. And one more we have, you can see these are the data points and the model is going through each and every data point. It is not missing any data. So this we will be calling it as overfitting. Overfitting means 100% accuracy will be getting when it comes to train, but test, it won't perform well. When it comes to testing accuracy, it won't perform well. So in that case, we'll be calling it as overfitting. It is when it comes to regression. What happens if it is classification? How it will perform? How can we say that it is underfitting or overfitting? You can see here. Normally, there are so many misclassifications. So normally, machine learning model, you can't build like with 100% accuracy, obviously. So here we can see there are so many misclassifications. So many misclassifications. So it is a underfitting model. So many misclassification will be having. So testing accuracy and training accuracy will be having huge gap. So it is an underfitting. If you tune that particular model, so whatever the model that you are using, if you tune it, using the hyperparameter tunings, some other. So here we have direct line. We will be doing some exponential. In that case, you will be doing some tunings, and then you have done the classification. You can see here, still we have misclassification, but compared to this, it's good, right? So we can say it is a best fit. And there one more we have. So 100% training accuracy is 100%. There is no misclassification at all. So it is performing good when it comes to training data, but if it is testing, it won't be performing good. It is performing good when it comes to training data. It is the best fit. It is underfitting because training accuracy is very low, underfitting, and this training accuracy is too high, so it is overfitting. Because there is no misclassification in this data. So this is regression and the classification underfitting and overfitting model. We'll also call underfitting as bias and overfitting as variance. So these are the difference we'll be having. How can we avoid that? How can we avoid that? Choosing the training, validation, testing data set. We can do that. And for the balanced data set, you can split randomly. So normally, whatever the data that will be into the test and train, it will be randomly taken. And if it is underperforming model, maybe whatever the features that you are taking, whatever the features that you are considering for the model, maybe it is not giving the best results. That could be one criteria. So what you can do, you can add features. Add features in order to improve the accuracy. Or if it is overfitting model, that means it is working perfectly fine on trained data, maximum accuracy that you are getting, but test it is not performing well. In that case, what you can do, we can go with regularization techniques. We can go with regularization techniques. What happens in regularization techniques, guys? We'll be tuning parameters, whatever the parameters. So we have so many algorithms like decision tree, KNN, and Nebase. Various will be having each and every model will be having various parameters. So we will be tuning those parameters according to those parameters at which the model is performing good. So we will be considering that parameter exhaust. And we'll make sure whatever the data set that we are taking, it should be balanced. And we'll be considering the validation data set as well. Take 60% into training, 20% into validation, and 20% into testing. You can take 80% into the training and 20% into testing. So we can do so many changes and in order to decrease those overfitting and underfitting. But if it is underfitting, in that case, the data set that you are providing or the feature that you are considering for the model, it is not giving enough information. In that case, it won't be able to perform better. So we have to go back and we have to understand the SQL and we have to understand that data problem statement. You have to understand the problem statement. What are the features required to predict that particular output? What are the features are missing? Or do we need to do any feature engineering? Feature engineering means whatever the data that is available in your data set, can we make new feature out of it? Can we make a new feature out of it? We will be looking into it. And if we are able to do it, that same feature we can consider for the data set and we can able to improve the accuracy of the model. So we will be having that one rule. Simple model, principle of parsimony. So that principle of parsimony will be having. The model is simple. In that case, it will be giving you good accuracy. So when you do the feature engineering, we are combining the two features and creating a new feature out of it. In that case, it will definitely having the both both features, characteristics it will be having. So in that case, we can decrease the number of features we will be having in our model. So like that, we can able to decrease the overfitting issues and underfitting issues. So this will come to classification as well as regression. Yeah, and here you can see when it comes to the data, how can we balance variance bias trade-off? Variance bias trade-off. So what exactly variance and bias trade-off? So we will be looking at one point. We'll be looking at, let's say, especially when it comes to K-NN, we'll be discussing in detail here. So we'll be having data something like this. And here we'll be using various values, let's say K values, K1, K2, K3, K4. When you are increasing the data, let's say it is test and train, you can say it is train and test data accuracies. These are the accuracies. When you keep increasing the data, in that case, train accuracies keep increasing. So here first we'll be having both training accuracy and testing accuracy are both low. In that case, we'll be calling it as underfitting. Both training and testing accuracy are both low. So you can see here the same diagram we'll be having. Training and testing, these are the accuracies we'll be having, both will be low. In that case, here we'll be calling it as underfitting model. So we have to find out one sweet spot. We have to find out one sweet spot where both training and testing accuracy are nearly equal, or exactly equal. Nearly equal or exactly equal. How can we find out that? When you take data, how much data you are taking on x-axis and accuracy on the y-axis. In that case, what happens? If you keep increasing the data, how much data that you are considering for the model, training accuracy, it is a training accuracy, it will keep increasing. So there is no limit when it comes to train accuracy. When you have much number of data, in that case, training accuracies keep increasing. And when it comes to testing, so when you are adding that particular data, it is also keep increasing. But at some point, let's say at some point, it will reach maximum and then it will start decreasing. At some point, it will reach maximum level, that is testing accuracy I'm talking about, and it will start decreasing. So here, this will be calling it as underfitting because both testing accuracy and training accuracy are low. And here at one point, it will be reaching the maximum, right? So this point, we will be calling it as trade-off, variance bias trade-off. Variance bias trade-off. And after that, you can see here, testing accuracy is low, but training accuracy is very high. So this is also so much difference. Here we will be calling it as overfitting. Overfitting. Here both training accuracy and testing accuracy is less. Here both training accuracy high and testing accuracy is low. In that case, overfitting and it is underfitting. We have to find out the sweet spot in between those overfitting and underfitting, so that both training data accuracy and testing data accuracy are exactly same or nearly equal. So this we will be calling it as variance bias trade-off. So that we can avoid the bias and we can avoid the variance. So this is all about the prime, guys, machine learning prime. What you have understood? what exactly what are the machine learning algorithms will be having? Both supervised and unsupervised will be having, and we have others as well, but extensively we'll be using both supervised and unsupervised. So when it comes to supervised, how we will be building the model? So what is the process? How data splitting is happens? So this completely depends. We are not always going with 80% and 20%. Sometimes based on data set, let's say you have 1 lakh 100K data set. In that case, we might be going with 80%, 20%. When you have 1 million data set, we don't need to go with 80, 20%. We can go with 90% and 10% as well. Because we have enough data to test. We have enough data to train. So we can simply go with the 90% and 10% as well. It is completely depends on the amount of data is available. So we can go with the 80, 20% or you can go with the 90, 10% as well. Yeah, that is splitting, data splitting. And when it comes to unsupervised, we don't have any splitting. We'll simply pre-process the data. Whatever the pre-processed data will be having, we'll simply feed into the machine learning model. When we feed the data into the machine learning model, it will come up with the rules. So using those rules, we'll simply segregating the data or we'll be making some classification. When it comes to here, we'll be splitting into the train and test. Using the train data, we'll be training the machine learning model. Using the test data, I'm testing the machine learning model, how much accuracy it is giving. But if you have more number of hyperparameters or parameters, what we'll be doing, we'll be adding the validation data set as well. So like that, we will be training the machine learning models. And then we have, when it comes to classification, we have confusion matrix. To evaluate the model, confusion matrix, error functions, you can say. And when it comes to regression, we have so many: mean square error, mean absolute error, root mean square error. So here we will be using the root mean square error. So that is all about the data, data science primer, guys. What are the that we have discussed. I hope you understood some concepts, that you will be having an idea about what exactly these algorithms will be having. And yeah, in next class we will be discussing about pre-processing techniques. So like in crisp MLQ phases, we have various phases, right? In one phase we have pre-processing. So we have discussed, we will be having anomalies in our data. So many anomalies will be having in our data. When you have anomalies, how we will be dealing with those anomalies? What are the techniques we'll be having? Various techniques we'll be having. We'll try to consider both structured data and unstructured data. In unstructured data, we'll be taking the text. In unstructured data, we'll be taking the text and we'll try to pre-process the data. We'll try to do the pre-processing in the next class. And yeah, thank you for joining, guys. And if you are interested to learn these things, in that case, we can continue with this series. And yeah, we'll see you in the next class. Until then, have a nice day.